Today we're talking about acids and bases. How do we measure them and what are they? So by let's begin by looking at our first slide. pH literally stands for power of hydrogen. And when we're looking at hydrogen or acids and bases, we're looking at the hydrogen ions, which is a positive molecule, and hydroxide ions, which is a negative molecule. We haven't talked much about ions in this class yet, so do understand that a molecule with a charge is an ion. And so if you think about it like this, it's like a magnet. The hydrogen ion has a positive charge, and the hydroxide has a negative charge, so they're going to be attracted to one another. Let's go to our pH scale. On a pH scale, you can see that we have neutral substance, which is 7. Let me draw on this for you. Our neutral substance right here is 7. And when we're talking about acids, we're going to talk about substances between 6 and 1 on the pH scale. So acids, as we said earlier, are substances that have hydrogen ions or H plus molecules. The further away from neutral that you go, the more hydrogen ions or the stronger the acid. And bases on the other side, 8 to 14, have hydroxide ions or OH negative. And 7 is neither an acid or a base. It's neutral. And something to keep in mind that a very common neutral substance, the neutral substance, is water, H2O. And we'll come back to that in a little bit. So let us go to our next slide. What makes an acid an acid? Well, we said it's the hydrogen ions. And an acid is a substance that is sour. An example of this would be citric acid, which is what makes lemons and limes sour. And if we look at this on a molecular level, we will see, if we look at this on a molecular level, we will see that water, once again, plays a very important role in making acids and bases. Because it's a polar molecule, remember it has that positive side and that negative side, so it can dissolve substances, breaks them down to their most basic parts. If you remember, we talked about salt, how it broke down sodium hydroxide or sodium chloride, NaCl, into two separate ions, Na plus and Cl minus. Well, the same is going to be true with hydrochloric acid, HCl. You can see that it's going to break down the HCl into H plus and Cl minus. Because the hydrogen has been removed from the chlorine, they're going to be hydrogen ions. What does this look like on a molecular level? Well, let's draw this out. We have a glass here. Make this a big glass. And make that a little bit more even. And so we have water. Let's make this denote H2O, which is a polar molecule, which is going to break the HCl down into H plus and Cl minus, its most basic parts. So let's put a couple more in here, H plus and Cl minus. Now the chlorine is important, but we don't really care about that right now, so let's ignore that. What's important is that it has hydrogen ions. Because this substance now has hydrogen ions, this makes it an acid. Alright, if we take that same idea and we apply it to bases, a base is a substance with an OH ion. These taste bitter, and an example of this would be cough syrup. And once again, if we look at it on a molecular level, it's important to keep in mind that water is the universal solvent. And I'm going to draw this out for you. Here is our glass. And here's our water, our universal solvent, which is going to break the NaOH into Na plus and OH minus. So in here, we're going to have Na plus and OH minus, Na plus and OH minus. So the Na, or the sodium ion, is important, but not for what we're talking about. So let's ignore that. And here we have a solution that has OH minus, or hydroxide ions. And therefore, this is a base. Another word for having something being a base is it being alkaline. So we're going to be measuring the alkalinity of solutions. Okay? If you combine a hydrogen and a hydroxide, or an acid and a base, then you get water. Let's look at this. Because the H positive and the OH negative is going to be attracted to one another, you would get H2O, or HHO. Let's look at this on a molecular level. If we have in this glass a solution, let's say it is an acidic solution, and let's put a couple more hydrogen ions. So we have an acid here. If we were to put a base, if we were to put OH minus in here, we would have combined OH minus and H plus, which would make H2O. This is water, which is a neutral solution. So when you combine an acid and a base, you're making water, you're making it neutral. We see this buffer or neutralizing agent in our stomach. We actually make a substance that buffers or neutralizes our stomach acid before it enters our small intestines. Here we go. Let's look at substances that neutralize an acid or a base is a buffer. So if you have a substance that adds H positive ions or hydrogen ions to bases, it's a buffer. So it's going to neutralize it. It's going to add the if you add H plus to OH minus, you get H2O. If you add OH minus to H plus, you get H2O. So a buffer brings everything back to neutral. And this is important in the concept of homeostasis. We talked about how your body regulates your body temperature. So if you get cold, you shiver, and that's what's going to keep you from getting too cold. And if you get hot, you sweat. And so your body regulates your internal steady state to make sure that you don't get too hot or cold. Well, the same is true for your stomach acid, or for your stomach, or for all of your pH in your body. But for example, our stomach, if we ate lots of lemons, our body would produce buffers to bring our pH level back up. So our pH goes up and down. Our pH goes up and down, up and down, just like our body temperature, because we're exposed to the outside world, but we need to maintain something around here, something around 7. Our body has to regulate it, and this is homeostasis. And this is our lecture on pH. If you have any questions, please feel free to come find me.